Welcome to ClickMyProject.com.
Now we're going to discuss about the project combination of SIFT and Canny edge detection for registration between SAR and optical images. Now we're going to discuss about the abstract of the process. The scale invariant feature transform, that is the SIFT algorithm, has been widely applied to optical image registrations method and other feature extraction methods. However, mostly because of multi-captive speckle noises, SIFT has been limited the performance when the directly applied to the synthetic aperture radar images, that is the shortly known as the SAR images. In this process, the SAR image registrations method is proposed, which is based on the combination of SIFT, nonlinear diffusion, and the phase of the congruency. In our proposed algorithm, the multi-scale representation of the SAR image is generated by means of the nonlinear diffusions. Since it is better, they preserves the edges in the images as opposed to the Gaussian smoothing, which is used in the original images of the SIFT images. To reduce the influence of the multi-captive speckle noises, the ratio of the exponential weighted average operator is used to compute the gradient information in the construction of nonlinear diffusion scale space. Moreover, the phase consequences information is utilized to remove the erosions key points within the initial key points which is occurred in the SIFT algorithm. Exponential results on the multipolarization, multiband and multitemporal SR measures indicates that our algorithm can prove the matching performance as compared with the older method. Hence the SIFT based method, which is leads to be the subpixel accuracies for all the tested image pairs. Now we're going to discuss about the flow diagram of the process. This is the overall working flow of this process. The module consists of this project as input image preprocessing, feature extraction, classification, identification, and finally performance estimations. These are the modules we have presented in this project. At first, the input image is taken from the dataset. The dataset consists of the SAR images, that is the synthetic aperture radar images. So after getting the image from the dataset, we just move to the second stage of the project, that is the pre-processing. So in this pre-processing, we have two kinds of pre-processing steps is there. One is the image resize, then the another one is the noise filtering. So image resize is done to resize the image into an aspect ratio of 256 cross 256, which means the number of row will be the 256, number of column will be the 256. The purpose of resize is to reduce the dimension and then maintain the optimum resolutions. After doing the image resize, we just move to the second stage of the pre-processing, that is the noise filtering. In case if the input image having some noises presented in the image, means it will be removed in the noise filtering image. So after doing the noise filtering, the feature extraction will be carried out. So in this feature extraction method, we have majorly considered the SIFT algorithm, that is belongs to the statistical features of the objects. So we have extracted the SIFT features from the images, then we have generated the test feature. Based on the test feature, the matching point will be generated based on the ransack method. So after generating these two methods, we are going to do the classification. So in this classification, first of all, we have to identify the distance matrix by means of the minimum distance and maximum distance. The purpose of maintaining the distance matrix is to classify whether the object is relevant to which category. So in this, we are using the SAR image. So we are capable to categorize which kind of SAR image is presented in the input image. After doing the classification, in the identification part, it will produce us the result, the name of the satellite images. After doing the identification, the performance will be evaluated. So in this performance estimations, the accuracy, sensitivity and the specificity will be evaluated to obtain the performance estimations. Now we're going to discuss about the running procedure of the process. At first, open the Scilab 6.1.1. After that, you have to change the current directory like this. After that, if you want to execute the process, just right click in the main file .se, then you have to click the option execute in Scilab. Now the dataset will be open. In that dataset you have to select any one image from the dataset, then click the button open. Now the dataset was selected and then the process will be done automatically. Now I am going to explain the results one by one. First of all, the input image. First of all, the figure 1 shows the input image which I have taken from the dataset. So the dataset consists of the lot of weather images, so we have to take any one image from the dataset. After the collection of the image from the dataset, we just move to the second stage of the process, that is the pre-processing. We have already discussed in the flow diagram. In the pre-processing, we are going to do the image resize, which means of the image of size of 256 cross 256. After doing the image resize, we just move to the third stage of the process, that is the noise filtering. In case if there is any noise present in the image, it will be removed by using the noise filtering method. So this figure 4 represents the SIFT features we have extracted from the image. The feature image is like this, and then the feature points is plotted in the blue color star marks. After extracting the features, we have to do the classification. So in the console window you can see the results of the pre-processing and up to the classification. In the pre-processing, it will be resized into 256 cross 256. Then the feature value we have extracted from the images like this. Then the classified label is 1, and then the classified image category is the cloud image. Finally, the performance of the process is accuracy, sensitivity and specificity. The process are displayed here. The accuracy is above 90%, around 98.9%. These values are plotted in this graph format like this.
Thanks for watching this video.